Hello everyone, today we are going to discuss about bending moment and shear force diagram. Myself Ganesan, working as an assistant professor in the Department of Mechatronics Engineering. Today we are going to discuss about a very interesting topic in solid mechanics, shear force and bending moment diagrams. They are very important topic in solid mechanics because it is the fundamental. If we understand what is shear force and what is bending moment means, then we can easily draw the shear force diagram or bending moment diagram for any kind of beam. In this video, we are going to discuss about three important points. First one is the definitions. What is shear force diagram and what is bending moment diagram. Second one is how to draw shear force diagram and bending moment diagram in a step by step manner. Third, we are going to discuss about two solved examples. One is from cantilever beam, another one is from simply supported beam. So, we are going to discuss about how to draw shear force diagram and bending moment diagram for a cantilever beam and simply supported beam. Okay. So, we are going to start with what is shear force. Shear force at a section of a beam is the summation of all the vertical forces acting on the beam or acting on one side of beam, either left side or right side. So, the unit for this shear force is Newton or kilonewton. Similarly, bending moment is the algebraic sum of all the moments of the forces acting on the one side of the beam. The unit for the bending moment is kilonewton meter or Newton meter. So, we will start with one example problem. This problem is based on cantilever beam. So, the problem statement is a cantilever 1.5 meter long is loaded with a UDL, uniform distributed load of 2 kilonewton per meter run over a length of 1.25 meter from the free end. It also carries a point load of 3 kilonewton at a distance of 0.25 meter from the free end. Draw the shear force and bending moment diagram for the cantilever. Before going to solve this problem, commonly beams are classified into 5 main types. First one is cantilever beam, fixed beam, simply supported beam, overhanging beam and continuous beam. Loads are also classified into 3 main types. One is point load or concentrated load, uniformly distributed load and uniformly varying load. So, in this problem we are going to discuss about cantilever beam with the UDL and point load. So, first of all we are going to discuss about how to draw the 2D representation for this problem. So, the 2D representation for a cantilever beam is like this. Beam, one end is fixed, another end is free. This is called cantilever beam. If both the ends are fixed, means this is called fixed beam. Simply supported beam means a beam is supported at both the ends is called simply supported beam. It has more than 2 supports, means if the supports are not at the ends, they are not present in the ends, means they are called overhanging beam, like this. One support is here, another support is here, another end is free, means this is called overhanging beam. These are the 5 different types of beam. This problem deals with cantilever beam. A cantilever of 1.5 meter long. So, draw a cantilever beam for the length of 1.5 meter is loaded with a uniformly distributed load. Commonly we are representing UDL load like this. This is the equation of a UDL load. Uniform distributed load of 2 kilonewton per meter run over a length of 1.25 meter from the free end. This is fixed end, this is free end, 1.25 meter from the free end. So, start from this point to 1.25 meter. 1.25 meter from the free end. It also carries a point load of 3 kilonewton at a distance of 0.25 meter from the free end. From the free end 0.25 meter. This is of a point load 3 kilonewton. This is the actual of this problem. Then we are going to draw the shear force and bending moment diagram for this problem. Shear force diagram, we must find the values for shear force value for the all the points. So, we name this point as A, this is B, this is C and this point as D. So, we have 4 different points A, B, C and D. So, first of all we are going to find the shear force value for point A, point B, point C and point D. Shear force at point B, there is no force acting on point B. So, 0 kilonewton. Shear force at point C, 2.5 meter for a distance of 2.5 meter, a UDL load of 2 kilonewton is acting. So, 2 into 0.25 that is equal to 0.5. At C 3 kilonewton point load is acting. So, plus 3 totally 3.5 kilonewton. This is the shear force value at point C. Shear force at point D, 2 into at a distance of 1.25 plus 3 totally 2.5 plus 3 that is equal to 5.5 kilonewton. Shear force at A, that is also 2 into 1.25 plus 3 5.5 kilonewton. Once we find all the shear force values at point A, B, C and D, then we can simply draw the shear force diagram. Draw a straight line, mark all the points A, B, C and D. So, shear force at point B 0 kilonewton, shear force at C 3.5. So, initially 0.5 then 3.5. Shear force at D 5.5, shear force at A 5.5. This is the shear force diagram for this problem. Next, we are going to find the bending moment values. point A, B, C and D. Shear force at point B, sorry, bending moment at point B. Moment is a product of force into distance. So, we need to find the moment at any point and the force acting on that point into distance from that point. So, there is no force acting on point B. So, bending moment at point B equal to 0. Bending moment at point C, 2 into 0.25 into 0.25 divided by 2. The force value is 2 kilonewton per meter. It acts on 0.25 meter. It concentrated at midpoint of this distance. So, 2 into 0.25 into 0.25 by 2, 0.5 into 0.125, 0.0625 kilonewton meter. Bending moment at D. So, 2 kilonewton is a value of UDL load which acts on 1.25 meter, which concentrate on 1.25 by 2. So, 2 into 1.25, that is equal to 2.5 into 1.25 by 2. So, the value is 4.56 kilonewton meter. Bending moment at point A, that is equal to 2 into 1.25 into 0.25 plus 1.25 by 2 plus 3 into 1 plus 3 into 1.25. Bending moment at point A, which is equal to 5.93 or approximately 5.94 kilonewton meter. Value for bending moment at point A, point D, point C and point B. Normally, we draw the bending moment diagram in negative direction, point A, point B, point C, point D. So, say bending moment at point B is 0, at point C 0.0625, at point D 4.56, at point A 5.94. This is the bending moment diagram for the given problem. Normally, we draw the bending moment diagram in negative direction.